Good afternoon, and thank you for joining us today. My name is Nicole Stickett, and I'll be your moderator. Before I introduce our panelists and co-chairs today, I want to introduce the 2023 Energy and Mobility Technology, Systems, and Value Chain Conference and Expo, this September 12th to the 15th at the IX Center in Cleveland. And I want to first set the stage for our discussion. Today, our chairs will be giving us a preview of their perspectives for the conference and expo. You'll hear more about the themes, topics, exhibits, workshops, and the keynote speakers. And to provide the best source of knowledge, we need experts like you to submit papers and presentations for consideration as workshops. And we'll talk a little bit more about that later. So make plans to attend this one-of-a-kind event and engage with leading experts, policy and decision makers, scientists, technologists, and system practitioners in critical topics, keynote addresses, panel discussions, and exhibits from multiple mobility and energy sectors in aerospace, defense, infrastructure, automotive, and commercial vehicle. But first, let me tell you a little bit about me and why I'm leading today. I lead the Sustainability Advisory Team for World Connect Energy Services, a subsidiary of World Fuel Services Corporation, a global Fortune 111 company. We provide energy, logistics, and technology solutions to the aviation, marine, and land sectors, and suppliers around the world. With nearly 40 years of experience, we facilitate the fuel, wind, and solar power, along with sustainability services and data management for international brands and businesses worldwide. I get to work with clients globally to develop their decarbonization strategies and help them reach their net zero goals. So while decarbonization efforts include electric vehicles, wind and solar power, carbon capture, storage, and green hydrogen have been notable, more needs to be done to meet net zero goals. It's critical that we quickly scale at the speed digital companies do to accelerate the transition to net zero. We at World Connect Energy see the energy transition not only as a global imperative, but also an extraordinary opportunity for us to leverage our technical expertise in global logistics and distribution to enable the transportation sector to make net zero goals a reality. We seek to continue developing sustainable supply chains that serve our customers today and enable them to take part in accelerating the energy transition to a net zero tomorrow. For years, we've strongly supported the increased availability of renewable energy and sustainable fuel products and related services in the aviation, land, and marine transportation industries. One example is our equity investment in Fulcrum, who is leading the development of a reliable and efficient process for transforming municipal solid waste into transportation fuels, including jet fuel and biodiesel. We've entered into a long-term agreement where Fulcrum Bioenergy will sell sustainable aviation fuel to us, and we will provide the transportation, blending, certification, and delivery services. It's an independent analysis of its biofuel shows a GHG reduction by more than 100% on a life cycle basis. And another innovative example is our investment in Meld Energy, a UK-based green hydrogen development company. World Connect Sustainability Ventures, a subsidiary of World Fuel Services Corp, has invested a 50% stake in the company. Meld Energy and World Fuel Services are working to develop green hydrogen supply chains and deliver net zero green hydrogen to customers across industry, ground transport, marine, and aviation industries in the UK and globally as well. So now I have the privilege of leading you now through a robust discussion with our 4 distinguished panelists and conference co-chairs. 3 organizations are collaborating on this dynamic event: NASA, SAE International, and INCOSE. Our panelists and co-chairs, John Juhas, President and CEO, Telepath Systems and INCOSE WG co-chair; Pascal Talon, Director of Aerospace Standards, Technology and Innovation and SAE International; Dr. AJ Misra, Deputy Director of Research and Engineering of NASA Glenn Research Center; and last but not least, Tim McCartney, Director of Aeronautics of NASA Glenn Research Center. Before we dive into our conversation, I'd like to invite Tim and AJ to give us more remarks about NASA and what's going on with the conference.
Be glad to. First and foremost, thank you for having us, co-chairing this with us. We are excited about hosting this event. I'm excited about being a part of it. So I'm looking forward to it for a number of reasons. It's not only it's in our backyard here, but really is, for me personally, as a director of aeronautics here at NASA Glenn, we have a tremendous amount of work involved that we'll be able to share with others and as well as learn from others at the Energy and Mobility Conference. So I look forward to it. In my role here at Glenn, again, I'm the director of aeronautics. So all of the aeronautics work that comes from headquarters funnels through my organization, and we provide the support and bring in the research folks and the engineering folks from across the lab to execute that mission. And a large part of what we do, because our core competencies are power, propulsion, communications, and high temperature materials for harsh environments. And these are all things that are just critically important to the future of mobility and energy. And it puts NASA Glenn right in the middle of it. So we are really excited about doing this.
Great, thank you. AJ?
Yeah, thanks for having us. And as Tim said, we are excited to host this event or the co-host for this event. It's an exciting time in energy. I mean, energy has been a part of my life for a long time. I've been pretty passionate about energy and power. In my old jobs, I headed the materials division where materials for power was the big thing. I remember 10 years back, we started the research on electric aircraft. That was 10 years back, and now see where it is going. And I managed the radio isotope power system program at headquarters not long back. So I have been pretty in and out of a lot of power and energy things. And so this conference fits into my background and interest. I'm pretty passionate about energy, climate change, sustainability. So this is the right conference where I can feel proud about it. And now with the recent introduction of mobility, that electric aircraft and space rovers. So I think that's the new area kind of evolving, and power is going to play a big role, and I'm pretty excited. And my current job is, as you said, Deputy Director for Research and Engineering, where we manage the Glenn's core competencies through 1,000 employees in our directorate. Is power, propulsion, comm, materials, physical, biological sciences, that's what we manage. But again, we don't see power as a power, we take interdisciplinary approach, combine power, intelligent systems, materials, everything else to develop the next generation that has big challenges. So we took a very interdisciplinary approach, and I pretty much championed that at the center to create that environment where different disciplines can work together, and this conference is right in that mix where different disciplines will come together. And in addition, I also serve as the champion for digital transformation for the center and lead the digital engineering for the agency. So that's another side role I do, which is pretty exciting as well. And that has a lot of big impact on the power and energy and mobility sector as well. So we'll talk about that as we go on.
Fantastic.
Thank you.
John, you want to introduce yourself?
Thank you, Nicole. I'm John Uhas. I'm the CEO of Telepath Systems. Telepath has had the privilege for a number of years now, almost a decade, for being the organizing entity of a conference called EnergyTech. We'll say a little more about that later, but my background is electrical engineering. I have master's and bachelor's here from a local university, Cleveland State. Hi, guys. And I'm very privileged to be the Energy and Mobility co-chair along with my very distinguished colleagues, and I really appreciate their partnership. So I'm looking forward to working with them. The Energy and Mobility Conference that we're looking forward to, it's kind of an extension of what we did with EnergyTech, as I mentioned. But it's also a major pivot with the expansion to include SAE and the mobility topic. So we're very pleased to have Pascal here supporting that. And you're going to see a slide about our themes. You're going to see it's a very broad spectrum of topics that fit under energy and mobility that we're going to deal with in this conference, including systems and supply chain topics. And they're all relevant to energy and mobility. Now, most importantly, I'll skip a few details until later, but I think the most important element is we're bringing together from the globe world's leading experts on this topic, people who are systems thinkers, engineers, and practitioners to address some of the most challenging and consequential topics of our time. And that has to do with the future of how do we integrate energy and mobility in order to be a sustainable, using that word, civilization. Our modern civilization depends on both of those factors to a great degree. Let me just expand on that point a little bit. I think we've hit a kind of a crossroads in our society today. We are deeply entrenched in two different camps of thought, and they're both very deeply dug in on their positions. On one side, we hear that if we do nothing, the future of the planet is, the planet's not going to survive. We're going to kill the planet. On the other side, we hear that if we spend all the money that's been put forth or proposed, and I've heard numbers like $150 trillion, that's 150 with 12 zeros, we may bankrupt all of humanity before we get there. So there's some very deep divisions on these two different schools of thought. So I would propose that we have some positive news to bring forth in this conference. I think we're going to be able to present a solution between those two paths that brings together a practical, rational approach to engineering our future, and that is providing clean energy. Everybody wants clean, safe, affordable, and so on energy. We're going to be able to find pathways to get there, and that's one of the things we hope to leave our next generation. We don't want to bankrupt them, nor do we want to ruin the planet. So I think that's one of our major missions of Energy and Mobility, to bring those topics forward.
So I'm going to have you pause right there, and so that we can bring Pascal into this conversation. Pascal, if you want to introduce yourself, give us a little bit of background about yourself, and then expand upon anything with regard to this conference and the involvement with SAE this year.
Correct. Thank you very much, sir. It's a pleasure and honor to be here with my co-chairs of Energy and Mobility Conference and Expo. So yeah, I have almost 30 years of experience in power, energy, and mobility. So I've been through various sectors. So power utility to begin with, producing electricity, and then I've also been with medical systems, like scanner systems, where there's a lot of, it's packed with power electronics, by the way. And then I moved on to mobility. So that's where I worked with airframers, and then I moved to the supply chain, so engine manufacturers and what we call tier ones, who are systems suppliers. So, currently we are in this energy transition phase. Everybody started thinking about the speed of transition, because that's what we need to consider as well. And the idea was to bring this concept of how energy and mobility are going to work together, given the current situation in terms of how everybody procures energy, the difficulties behind, and the types of energy which are going to be used, and how are they going to play together a role in delivering solutions to any type of mobility solution. Like it could be automotive, commercial vehicle, space, and also aeronautics. And so having this conference here in Cleveland is also symbolic due to the fact that there's a whole lot of work going on in the aerospace sector in Ohio State at large, and especially in Cleveland with Glenn Research Center, NASA's Glenn Research Center. And we also need to think about the engine manufacturers out in Ohio State, like GE in Cincinnati. And let me tell you, any single, we call it either single aisle or narrow body, the short-range aircraft like Boeing 737 or Airbus A320 family are fitted with an engine made by GE in cooperation with Safran. So this is really a great opportunity to think about all this. And at this conference, we're going to make these experts tell the audience what they think about all these paradigm shifts. And we will come back later on that, but yeah, that's my short introduction.
Yeah, absolutely. No, thank you for that. And maybe if you can, we'll stick with you for just a moment and have Tim chime in here, but what factors or inner challenges motivated you to co-develop this event and get SAE International involved?
That's a great question, because SAE International has actually 3 pillars, if you will. So one of the main pillars is standardization, because the industry needs standards. Because technology is there, but at one point you need to bring the technology into a product and a certified product. So for that you need standards. So the work that SAE does in the standards domain, this is both for automotive and aerospace, is to bring together the industry in various committees. We have almost 180 technical committees where industry research centers and also the authorities, regulatory bodies, discuss how to establish the standards and means of compliance to certify ultimately a product. So that's the first pillar. Second pillar is to do with events and forums, because SAE's role is to connect the mobility industry together and also offer neutral forums where every topic can be discussed without any taboo, so that's what we offer. So this event is typically in line with that second objective of sharing information and connecting engineers and professionals and business leaders together. And the third pillar is publishing. So SAE publishes books, journals, and tech papers and things like that. I personally wrote a book called Fundamentals of Electric Aircraft that SAE published, and in there are a lot of contents on the research work done at Glenn Research Center. So there's a lot of information which is now getting into the air, in the form of flight demo, so going on. So yeah, so I think that the reason why SAE is with now NASA and INCOSE is to bring the energy concepts and connect that with the mobility constraints, because there are a lot of constraints that we will touch on later, and not to mention the infrastructure part of all this, which is a huge challenge right now.
Tim, do you want to elaborate anything further?
I will, and I think I'll pull on a thread that John had mentioned about, that the systems perspective. If we are going to address the challenges that we're looking at in the future, we really need to look at it from a systems perspective, and to go in and look at technology solutions for strictly, energy or strictly mobility, we're missing the boat. We really have to do this together. We look at the density and diversity of aircraft that will be flying from an aviation perspective into the future. We have to look at both of them together. We can't do these independently. And I'm sure the same is true for other industries as well. But you'll hear some more coming up here about some of the projects that we're working on in the Aeronautics Mission Directorate, but none of them are just focused on one thing. It really is building technologies to get to a demonstration so that we can do the mobility and the energy piece together.
So expand upon those emerging technologies and the drivers impacting energy and mobility today, and I'll invite AJ also to chime in there as well. Either one.
Yeah, I think the energy has been there with us for a long time, but the mobility is something that has come recently with the electric cars, electric planes, electric ships in the marine industries, and boats. So that's kind of something new that, and where it is intersecting is we see that energy for the ground power is different than for the mobility. It has to be a new paradigm, because you cannot stick anything in a car. It has to be lightweight or something, different things on the plane. So that's where it's intersecting. How do we integrate the energy advances with the mobility? And one factor that is driving is the autonomous thing. Everything wants to be autonomous. And how do you create the autonomous systems in the mobility sector and integrate with the power systems as well? Because if the power is going to be autonomous, then how do we integrate that with the automobiles? In fact, people say that it is such a autonomous thing is such a important thing. People say, is it car or is it a computer on a wheel? Or wheel on a car? It's a debate. Is it a car company or a software company? So that's kind of where we are today, that autonomous things are driving the whole business of power as well as the mobility. So that's where I think a lot of those things are going to intersect in a different way. And that's exciting, because where mobility is intersecting energy is, I think mobility is driving the new energy in some ways, because mobility is driving the batteries, the new energy, hydrogen fuels, and all those things. So mobility in many senses is driving the future energy resources and the climate change. So that's the key factor. So the climate change is bringing those guys together, sustainability and the climate change that we want to achieve in 30, 40, 50 years, that 1.5 degrees C temperature increase, that we want to limit that. So yeah, that's exciting.
Tim, anything to add to that?
Yeah, so with AJ's organization, they really work on those technologies, and what we try to do in the Aeronautics Mission Directorate is trying to pull those together, right, the more systems perspective, and advance those technologies into labs, into ground testing, and then on into flight. One of the things that we have right now, the big push in aeronautics, is what we call the Sustainable Flight National Partnership, which is across several projects, several programs, other agencies are involved. But in there are a collection of projects that have matured technologies at different levels and will come together to impact with that next single aisle that Pascal mentioned is going to look like and be competitive in the 2030s. The electrified powertrain flight demonstration is from years of work, as AJ mentioned, the past 10 years we started working on electrified aircraft. And now we've run full megawatt scale powertrains and we're going to fly it. This came out of other projects that we have been working on for a long time. We're working on new engines, trying to create, with new materials and new coatings, create the core of an engine to make it smaller and therefore more efficient, increase the bypass ratio, and get 5 to 10% fuel burn reduction out of it, as well as up to 20% power extraction to make an aircraft more electrified aircraft, if you will. And then back to that kind of systems perspective, it can't just be the power plant. We have to look at the airframe itself. There's a transonic truss-braced wing. Over the past number of years, did a significant amount of work in wind tunnels. And now we have, back in January, just announced a sustainable flight demonstrator. We will fly a transonic truss-braced wing in a few years, but again, 5 to 10% fuel burn. And finally, part of that mix, and there are others, is the airframe itself. We're building lighter aircraft, and they're composites. And we can do it today, but we can do it at a rate that's single digits to low double-digit numbers. We really need to get those numbers up to 60 to 80 aircraft a month to be competitive in the 2030s and 40s. So we have a project that's looking specifically at the high-rate manufacturing of these vehicles. So there really is, we're touching it at a number of places, and it's not focused on any one technology, but really trying to bring it all together to address the kind of issues that we have in the nation, in the world.
That's great. So, Tim, you touched on the transportation electrification theme, but why is this such an important topic, and what is the interplay with other types of fuels? And Pascal, I'll ask if you want to chime in on this question too.
Yeah. Electrification, is actually bringing in efficiency gains. So first of all, using electrical energy is actually reducing the energy consumption, if you will. So having a portion of electrical energy in your configuration is always beneficial, right? Now, we have batteries, which are good for certain applications, but due to some limitations, you can't do everything with batteries, even though technologies are progressing. So how do we complement the energy to be able to have all the energy on board? So that's where the other types of fuels come into play. And typically you could use sustainable aviation fuels to run what we call turbo generators, which could also produce electricity. So there are many sources of electricity that you could imagine: batteries, turbo generators, and after that we have hydrogen could also play a role, and it plays a role in many areas in industrial application, but also in commercial vehicles and in the automotive side. These fuel cells are also candidates for implementation in an aircraft, but they use hydrogen to work, and they have no emissions. So the idea is to have a fuel-efficient aircraft, and Tim mentioned that the engine could do so much, but also the aircraft needs to bring in more efficiency. The reason why the current trend is to change, both have fuel-efficient engines, but also change the shape and aerodynamics of the aircraft. So yeah, so there's a lot of themes, and there are a lot of challenges as well in terms of how the industry is dealing with, procuring the sustainable fuel, because that's a huge challenge. It's a practical challenge, but there are many plans right now to kind of increase the uptake, and there are many considerations like what are the incentives, what needs to be done, so that this can also play a key role in the transition period, as I mentioned. Like while the new aircraft is going to come and enter into service, like for the single-aisle market in 2035, what are we going to do between now and then? The low-hanging fruit is sustainable aviation fuels, right? So, but as I said, it will continue to play a role in the hybrid electric configuration, where you have partially electrified, and you could still run some elements on sustainable aviation fuel.
Absolutely. Anything to add to that, Tim?
Yeah, you took the words out of my mouth, right? So we talk about electrification of aircraft, and it gets a lot of press. There's a big announcement last year at Farnborough about what we did with GE at our NASA electrified aircraft test bed, and first time we ran a megawatt class powertrain at altitude. Gets a lot of press, but it's not to say there's not a lot of other work going on in SAFs We don't create the SAFs and things, but we will make sure that they can work in the combustors and that they look at the materials and things. Fuel cells and hydrogen, we're working on those, but the timeline for those are a little bit different than the electrification. So the electrification of the aircraft is getting a lot of press, as it should. NASA and the industry have done a lot of studies about the benefits of it. AJ mentioned back 10, 12 years ago when we first started talking about electrification, it went right to what you said. People said, you're not going to put that many batteries on an airplane, but that's not what we're doing, right? We're going for the hybrid solution and taking that low-hanging fruit, developing the technologies that we need to get the more electric aircraft. And we're making impact. We see impacts that'll happen in the regional air mobility, small aircraft market. We'll see impacts all the way up to the single aisle, where we can get not only megawatt class, but beyond that, tens of megawatt class to impact that market. So the Aeronautics Mission Directorate really is committed to making an impact and doing this and making the investments that are necessary to get us there.
That's great. So this is a question that probably any of you could answer, but how does energy intersect with mobility? Why is it important? Why is it important specifically for climate goals, infrastructure, and resiliency?
I'll take a
Who
shot
wants to
at
start?
that. Sure. It's, well, energy and mobility, it doesn't take a long stretch to recognize that both mobility and energy are vital to supporting modern economies. Without either one of those, the economy grinds to a halt, and therefore civilization can't be sustained using the sustainability argument. I recognize also that mobility critically depends on the availability of energy. Again, we want to go back to cheap, abundant, clean, and safe energy as sources of mobility. Without that, you can't make it happen. The problem we have today is with all the developments, all the technologies that are coming forth, is an increased dependence on having more energy, more electrification, and so on. At the same time, it looks like our current energy outlook, at least in the U.S., and I suspect that it's probably global, is on a decline. For what appears to be good reasons, we have cut back on fossil fuel production significantly, although the economy still needs that. And the electrical grid, which is going to become all important, even more important for electrification, is in a sad, fragile, vulnerable state. It's a system that's been called the world's largest machine. It's been in existence over 100 years and evolving. And today, it's vulnerable to a whole number of potential threat scenarios. We heard, of course, a lot about cyber attacks all the time. Every day, there's a new cyber attack somewhere. We also now are hearing people shooting out substations with machine guns and knocking out power in significant areas. This seems to be happening with greater frequency. So there are people who are interested in taking down our grid. So imagine as we go forward with the electrification, increasing demand for electricity, if we lose a significant portion of the grid, we will now just not shut down the electricity, but also a significant part of transportation. I think those are very dire consequences. The good news is that I think we'll be able to introduce in this conference some roadmaps ahead going forward. How do we improve the grid? How do we increase our capacity? I'm going to use the term microgrids, which are in the news a lot. We're going to have significant topics that deal with microgrids. And they are capable, of course, of island mode operation. They inherently decentralize instead of depending on a centralized grid, which can be subject to failure points. And I think that this evolution is going to be vital to the critical infrastructure that we'll have as we go forward with electrification. Microgrids will add additional capacity as well as the reliability to be able to separate from the grid and avoid these threat scenarios. And I think that the microgrid architecture is far better suited for integration of renewables than the massive grid and the solar farms and the wind farms that we see now. So I think there's an opportunity here that we want to fully evolve and make note of in this conference with a number of topics. I think we'll be able to realize the achievement of both resilience and with increased capacity by approaching this kind of an architecture. So we look forward to those kind of contributions.
Excellent. Those are all fantastic topics to look forward to at the conference. AJ and Pascal, this is a two-part question. Which communities are involved in energy and mobility, and what is the relevance to the space program? Tech transfer, et cetera.
Yeah, the companies which are engaged is obviously the automotive companies who are electrifying their cars, aviation industry which is electrifying their planes, and the aerospace space sector. Again, power is a big thing for the space side of the house, and the Department of Energy, which has huge budget now to develop next generation of energy sources and power systems and the grids, and the national labs. And I think one thing coming up is some of the new companies. I mean, the new players are coming into the picture, like as you grow autonomous cars, autonomous planes, autonomous power systems. There are people who didn't play a role in the power and energy. Now they're becoming a big player, like Google's, Microsoft's, and all the software type of companies, and with artificial intelligence. So they are playing a big role in the power and energy sector, because when they talk about microgrids, how to create autonomous microgrids. You don't want to just humans do it. It is impossible for the humans to do it. So how do we apply artificial intelligence to do those microgrids? So those are the new players that come in the horizon, and they will continue to play a big role, and we will bring them together in this forum with the kind of software people and the automotive people, battery companies, and the manufacturing, because that's another thing, like how to make these batteries, how to make these motors, and that's a big supply chain issues, and we'll bring those together. So the supply chain companies, manufacturing companies, so they will all come together at this conference. So it's multiple players, including NASA and the national labs, and government agencies, and DOD, Department of Defense. They're big on the things, and the sustainable aviation fuel producers. And so those will all come together, I think, for this conference.
Good.
Right, and I think, I mean, the keywords, like John mentioned, and AJ, you mentioned, like reliable and dependable. The word dependable is I think the most important thing that people are looking for. Like, I mean, can I depend upon on my infrastructure, on my power source, and things like that. And in terms of mobility solutions, and you mentioned the technology transfer taking place between automotive and commercial vehicles and aeronautics. So batteries was one of those examples, fuel cells as well, and we can also see hydrogen between space and aeronautics, because hydrogen is used in space launches since a long while. So how do we transfer that technology to aeronautics and make it safe? Because one of the key things, as I mentioned previously, is like, I mean, how do we establish the means of compliance? So all these discussions are going to be had at this conference. And coming to the autonomous side of things, like, I mean, there are a lot of things going on make things fully autonomous, but also semi-autonomous. Like, if it's still the pilot or the driver in the loop, right? And that kind of thing brings up the question of, situation. We call it situational awareness. How is the pilot or driver aware of what's happening around him? And so this is creating a lot of activity. Like, I mean, how is the information being presented to the driver or the pilot? So in terms of virtual reality or augmented reality, synthetic vision. So there are so many things at the cockpit or at the car level that we will also consider. And the flying cars, we call it flying cars. I mean, these urban air mobility vehicles, also commonly called vertical takeoff and landing, eVTOL aircraft. Those and they are under pressure, I would like to say, in terms of how to make the manufacturing sort of things are compatible with a high ramp rate, and they are looking into the automotive side and learn the lessons from what they can offer. And then also, I think in Ohio State there's a platform for flight testing, and actually supported by the DoD for certain eVTOL manufacturers, because at the end of the day, it's the huge amount of flight testing which is going to prove your capability.
Exactly.
Can I come back to the space side? I didn't address
Yes,
that.
please.
So space, power is the big thing for space. We need power for everything, spacecraft, rovers, to stay on the moon. When the astronauts get out from the spaceship and go do their work outside, they need power to batteries. So power is a big thing for space. We do leverage what is happening on the ground or the energy sector, a lot of technologies like solar cells, batteries, fuel cells. So we do leverage a lot of things that is happening. But what is key for space is weight is the premium. You want to have lightweight. That means we want all the systems to be high energy density, high power density, lightweight. And how do you take them to the space? Because you cannot, just like solar cells, you cannot take a big array to space. So we have to store them somewhere, kind of make them and then open in space. So we have the solar arrays that we just kind of group them together and deploy them at space. So those are some of the things we do specific to the space. One big thing is the nuclear power. When you go to the moon, you want to stay for longer, then you need nuclear power. I mean, you cannot do solar cells on the dark side. So nuclear is a big thing for space, and we leverage all the nuclear things happening on the energy sector. So like how to build 10 kilowatt reactors, 20 kilowatt. So that is another big thing for this space side of the house. We leverage a lot of things, but we have some unique needs as well that we do our own development on those things.
Great. Pascal and Tim, I hear that the business value chain and supply chain theme is new to the conference this year, which, I've heard many of you speak, to elements of the supply chain here today. Could you explain how this connects with the technology and systems theme too?
Right. Technology focus and systems focus is the main focus of this conference. So, but what is new is this, as you mentioned, the business chain, supply chain, value chain, if you will. So what is that? Typically, it's looking at the end-to-end scenarios of how energy is going to be used and mobility going to operate applications and so on. So that includes, for instance, technology transfer. So how whether small businesses or large businesses, if they are going to transfer technology, what does that mean in terms of investments and things like that? And coming back to infrastructure, so one of the key sticking points I would like to say is who's going to invest, right? So, and one of the main thinking is it's the private, public-private investment scheme, which has to be thought about, and this is what we're going to enable. Because without infrastructure, you are not going to be able to operate any kind of vehicle, whether it's on the road or in the air. So I think that's the main thing. So what does that mean in terms of investments and things like that? And coming back to emissions or costs, like we get into what we call life cycle analysis, like what are the emissions like? Because we need to think about, you can have a fuel efficient vehicle, aerial or ground vehicle, but if the energy that this vehicle is using is being produced with a lot of emissions, does it make sense end to end? So these are things that we are going to consider. And Tim mentioned this, how you ramp up your production rate and make it simple and compliant. So that's also one of the key things that will be. And then NASA is running a program called Agility Prime in order to tackle those challenges for the urban air mobility side of things. So, and then comes, any new technology. How are we going to manufacture this technology? So what is needed? And then we can also think about, how you protect your inventions. Like anybody who has a solution, research center having an idea, a solution, make it turnkey, and also licenses it out to anybody from the industry who could make use of it. So these are things that we will be exploring in the business value chain.
Tim, do you want to speak more to the Agility Prime? And
So Agility Prime is a DoD effort down there. We'll have a presence up here, but there's several parts of Agility Prime, but essentially it's to bring and strengthen the industrial base to make sure that we are, as a nation, competitive in the advanced air mobility market. I'll pull on the whole tech transfer thing a little bit. So, we often remind ourselves that we work for the American people, right? So what we're doing, and especially in aeronautics, it really is, it's got to have an impact on the economic viability of this $1.8 trillion aviation market in the United States. So at lower TRLs, lower technology readiness levels, we have means to go through an innovation and partnerships office. You mentioned the licensing. Over the past several years, we have orders of magnitude increased our licensing of technologies, patents and things that have gone out to make sure that we get it out there. Because we do it and put it on a shelf, it's not doing anybody any good, and it's not doing the taxpayer any good. As we mature those technologies into bigger projects, and now with some of the flight demonstrations, the way we're doing and managing these, they're not simply contracts that we write, these are partnerships, true partnerships with the big companies, with GE, with companies like Boeing. I mentioned the Sustainable Flight Demonstrator is a completely different contractual mechanism. Boeing's bringing more dollars than we are to make this happen. So we are in it to help move this along. But if they didn't want to do it, if they didn't see, a carrot at the end of the road to make this happen, we're not in it. We shouldn't be in it. So there's a lot of tech transfer, and it occurs at all levels of maturity.
John, you want to add something?
Yeah, I'd like to add something. I'm very pleased to hear my co-chairs emphasizing the importance of systems approach, of systems engineering. Of course, I'm here representing the INCOSE organization as the third partner in this endeavor. Many of my early engineering years I spent right here at Glenn Research Center working on the International Space Station, which certainly at that time was often touted as the most complex system ever developed, and of course it had to be built and assembled in space. So there are a lot of complexities that went along with that. Successfully, we're still flying, and it's a great testament to NASA's persistence. The system engineering, the systems concept, that's often confused with technology, as though systems is the same as developing technology. It's different. It's the approach that addresses, first of all, the needs of stakeholders. People that, in our case, the stakeholders are the citizens of the world right now with our conference. But the needs of the stakeholders are expressed as requirements, and then you just start the system life cycle, which integrates all the essential technologies. So focusing on the technologies is important. Putting them together in an integrated fashion is absolutely critical to making that system behave properly and deliver the value that is sought by the stakeholders. So that's why this conference is going to emphasize, and as Pascal has said, supply chain and all those elements that need to be integrated are part of a system philosophy, system approach. So integrating energy and mobility is going to be vital to our future, and I think that we're going to play a significant role and emphasis on the systems aspects, including what's now called model-based methods or digital engineering, and there's a lot of emphasis on digital transformation of enterprises. I know that there's some points of view on the NASA side for that, so appreciate your thoughts on this.
Yeah, that's actually a great segue into the next question that I was going to ask is with regard to the relevance of systems engineering, digital engineering transformation. So John, AJ, Tim.
I can talk about digital transformation. I think, I know that's the kind of the what they call fourth industrial revolution, where it is more digital, data-driven engineering, data-driven science, discovery. So NASA, we are pretty actively engaged in digital transformation, like to transform engineering, transform our research discovery processes, transform decision-making, transform our operations. So, but what is critical to the energy mobility will be digital engineering, where we want to go from document-based processes to model-based processes. That's a big thing. And we do apply a lot of modeling and simulation in an integrated fashion with the CAD drawings and create that thing so that we can design the whole plane from the get-go at the beginning using digital tools so that we don't have to do a lot of experiments. And then with the virtual reality coming in, you can try a lot of things like thousands of new designs pretty quick with this, what they call generative design or the artificial intelligence. You can try a lot of designs pretty quickly on the computer before you even build a single model. So that's where the digital engineering playing a big role, and you create a thread, talk about supply chain from the beginning, supply chain mining to the final product and the recycling. You create the digital thread from the beginning to end and all connected by data and the digital principles, and so that you can do manufacturing based on your digital things, and then you testing and validation. You don't have to do a lot of testing. You do few tests, but you optimize those tests based on digital tools. So that's going to play a big role in the energy mobility. How to create these new cars, new planes, new boats, new spaceships, that you combine everything together from the beginning that we didn't do before. We were kind of siloed before, compartmentalized, like do one thing and hand over to other people. But now we can do everything together in this new era that is emerging as the fourth industrial revolution. And a lot of big data, like you have all the sensors, Internet of Things, they're connected together, and the big data is playing a big role in designing things and your maintenance, predictive maintenance. You don't have to maintain everything on a regular basis. You can do when you need it. So those are getting a lot of operational efficiencies for the power plants and the cars and the planes. So it's a fascinating field that we'll see explore. And with the recent introduction of chat and GPT and all those things, we don't know where it's going to end. But it is, I think it is taking a lot of. One big thing is it's taking a lot of mundane work out of the humans, so that we can do more creative things. So this is pretty exciting.
Okay, so we, in recognition of that, and largely his organization as well, but we have talked about the Sustainable Flight National Partnership, where we're looking at engines and airframes and manufacturing and electrification. but they're all separate projects that have their own timeline. So how do you stitch all these together? So we have a model-based systems analysis and engineering project that spans all of them, that will stitch those benefits together, and rather than trying to build one aircraft that has all of those technologies packed into it, and be able to assess the system-wide impact of those technologies. So we're certainly investing in projects like that.
Exciting. Well, let's talk about exhibits that we might see this year at the conference. Pascal, can you talk about some of the advanced tech exhibits that are planned this year? What can we expect to see on the trade show floor?
Correct. So in terms of exhibits, I mean, we are expecting airframers to come and showcase prototypes. So we call them markups. Markups just for people to see how these vehicles are looking like. And there'll also be showcasing of technologies and digital solutions and products, So the exhibits will be displays, so big vehicle displays and technology displays, but also booths. There'll be a lot of booths where industry, big and small, can come and show what they have to offer. And we are thinking of course, I mean, focusing on small businesses as well, and so that they can have a special area where they can connect with the overall aerospace community.
So great collaboration of the whole supply chain coming together,
Yeah.
that everyone can be interactive and have a dialogue with the booths and the experts there. Pascal and John, how does the E&M conference approach sustainability considerations for mobility applications and energy alternatives?
Great.
Well, as I mentioned earlier, with the evolution and emphasis on redesigning and transforming the current grid architecture we have, emphasize the evolving technology called microgrids. I really believe that microgrids offer an architectural approach that's much better suited for integration of renewables. And I think that's going to be the salvation of the current grid. As I mentioned, we have tremendous vulnerabilities and weaknesses. In order to support all the mobility evolution and the demand for increasing electricity, we're simply going to have to do a lot more to shore up our energy and electricity production. And this is the capacity increase that we look forward to with microgrids. Another advantage is with that technology, we can introduce a number of different power generation sources, including hydroelectric, of course, and geothermal, and things that are not exploited right now. They're out there, they're available, their potential is there, but they have not yet been fully leveraged and taken advantage of. Some exciting developments are taking place in the energy labs. I've been talking to some colleagues, and we're in discussion about things like micronuclear reactors that are capable of producing several hundred kilowatts as a source of a small microgrid, like for critical infrastructure, like a hospital, for example. If we lose power to our critical facilities, like hospitals or water systems and so on, you lose a lot, all right? So we can't afford to have a grid collapse and cause that kind of a destruction. We think the microgrid solution is going to be able to introduce a lot of these kinds of technologies and solve that problem of decentralization.
Good.
And and John, you're right. I mean, in terms of how, for instance, sustainability is everywhere, And when you look at how energy is produced, it could be done in a sustainable fashion, and that's what people are looking at, like producing electricity, but also they call it cogeneration. You could produce heat as well. And so there are many considerations right now when you look into mobility, like airports kind of wanting to do their own power generation and do it in a sustainable fashion, and they wanting to bring in hydrogen. And one of the things that we also see is, for instance, I would like to call it low-hanging fruit. Once again, it's the carbon capture technologies. Okay, well, I think that this is going to leverage a lot in the transition period, if you will, before we move to a completely sustainable fuel. And the other thing that I would like to mention, we call it, the concept of well-to-wheel. What are the emissions between the point when you extract the oil from the ground and you put it into a car, right? So That's a very important part of it. So it's the full picture that we would like to bring and discuss. And of course, all like I said, carbon capture and utilization systems. So these are things that we are going to be discussed. So, but when you look at an airplane, like let's say A320 or a Boeing 737, well, 98% of emissions are coming from operations. It makes sense, but and then you do have a lot of things like, I mean, how do you manufacture? How do you design your plane? And so what are the sustainability aspects of that? And how do you manufacture your plane, right? So, so like, I mean, reducing the time for developing a product using digital applications is kind of, I mean, contributing to this, so yeah, and how you kind of reutilize or recycle waste. You know, so then we get into the circular economy. So all these will be discussed. Yeah, all these topics will be discussed.
Yeah. So last question for all of you: if you could give, one or two sentences, which I know may be tough, but what does the future of this conference actually look like when we look 5, 10 years out?
Okay, I'll take a shot at that. I think this is the beginning of a long series. We're not going to solve all the world's problems in one conference, in one 4-day event. We think that this is the beginning of let's say, call it episode 1 of season 1 of a series of events where we continue to evolve the capabilities that we're talking about, the integration, effective integration, with a significant carbon reduction. That's our goal. We want to get to a net zero world. But I think the roadmap to getting there requires this kind of a systems approach, the disciplines of bringing together all the technology. So I foresee, with the help of our colleagues here, that this conference will continue to gain more momentum and go forward in the future years. Hopefully we'll arrive at a point where we don't have to ruin the planet or bankrupt our children. Okay.
Pascal?
So yeah, I think if we could go back in time, typically this Energy and Mobility Conference used to be called EnergyTech, right? So in that form, typically we were kind of building the concept of moving into energy and mobility. So let me give an example. Like we with the engineers from NASA, we ran a workshop with the help of engineers. We ran a workshop on high voltage, as you know, in cars, electric cars, and even electrified planes. You have what we call high voltage utilized due to the power needs on board. So this workshop actually went so well that actually at SAE we started off a committee called High Voltage, and we have more than 200 industry participants, right? And Boeing is actually chairing this committee. So the benefit to the industry as a whole is something that we don't need to prove with this Energy and Mobility Conference. The thing is, we are bringing in new contents, like you said, business and value chain track, and also I think we mentioned it briefly. We are setting up to 8 workshops, interactive workshops, where a research center teams, I mean, from NASA, will co-lead with industry participants all these workshops. So it's really connecting industry with research work being carried out all over, and so that is a huge benefit, because when you come to a conference like Energy and Mobility, there's always, I like to say, there's always a takeaway they're going to have, and they also have their say, because they're going to speak, give their opinions, and that's what is going to make this a great event in the future. And
sounds like a conference nobody can miss. AJ?
Yeah, I think if you look at 5-10 years, I think the mobility part, you will have more electric cars, more electric planes. That equation will be slowly evolving and it will be expanding. Where you'll see more emphasis on the energy sources. Where is the energy going to come from? Renewables, it's a mixture of energy. What is the right mix of energy? And how does it translate to policies at the government level, country level? It will be more geopolitical, and the policy decisions will be key at that time on the energy resources. So we'll probably see more papers on some of the papers on the policies level. We haven't seen that, but that will be coming, I think, because that's going to drive a lot of things we will do in the future. So you will see more energy resources and sustainability. I mean, I think as the cars are built, we get more energy, but how do we make them? Manufacturing sustainability will be a big thing. Material sustainability is a big thing. So those will be becoming more important along with the policies to deal with those things. So that's my guess.
Tim, your thoughts?
In 5 to 10 years, my vision, I would love to see is that the people that are out there, the entire supply chain that are folks that are developing technologies, that when they're thinking about sustainability, greater mobility, and kind of economic growth in the industry, that this is the place that they want to be. This is where they're going to get their information. This is where they're going to share information, and really be a part of that transformation. It's, at least on the aviation side, whether it's ultra-efficient aircraft, high-speed travel, airspace operations, which is another part of it. We're doing a lot of work, or in advanced air mobility, that this is the place that they want to come and be a part of, right here in Northeast Ohio.
Absolutely, right here in Cleveland. So as we close, I'd like to thank you all for joining us today and extend a sincere appreciation for our distinguished panelists and co-chairs of this conference. As we end, a few reminders. So we will have 2 upcoming webinars prior to the conference, September 12th and 15th in September at the IX Center in Cleveland. Again, you can go on the website to submit your presentations and abstracts for consideration. Again, you can do that on the website. And I'd like to thank you all again for joining us today, and that's a wrap.